plan for today's agenda is to give an overview about what Google Cloud Smart Analytics is all about. And the most important thing when beginning with the big data analytics is to bring the data from whatever source that you have. So the data pipeline becomes the crux of any big data analytics project. So we'll be walking you through some of the data pipeline solutions that we have within GCP. The third one is once we pipeline the data, you need to have a centralized place to basically store this information and then do any kind of reporting. So we'll be covering those aspects. And finally, a quick demo that how you can utilize all the Google Smart Analytics solution to create your own application for the hackathon, right? So what we'll do is we'll basically show you that backend could be any data warehouse, any BI solution, but the front end could also be anything. It could be, say, for example, a bot, an omni-channel bot, and you can interact on WhatsApp or interact with any other system. Or it could be an app, right, where you can actually take the data from the data warehouse, or even digitize your data and store the data into the data warehouse. We'll walk you through a couple of demos in that space. And what we'll do, because it will be more of a one-sided kind of affair, where I'm going to just walk you through the presentation. I believe the last 5 to 10 minutes, we'll just keep it open for rest of folks. But don't be disheartened. You can just ask your questions on Google Meet and try to respond at the end of the session. I'll not take much time. I'll just quickly walk you through this. So before we get into what Big Data Analytics platform Google has, just to give you a brief about the components that actually runs through the Google Smart Analytics platform. The first part is the data, right? So this data might be actually coming from different applications. Some of the data might be streaming, some of the data might be in a batch process. So we have systems which basically helps you to collect this information, right? Now, you might see a list of products down here. I'll not go very detail into it, but some of the components like Google PubSub is basically as a fully managed real-time messaging services that basically helps you to send and receive messages between independent applications. So let the applications be a clickstream application where you're going to send that information to an endpoint into PubSub, and the PubSub will bring that information and store that information for some time till it is being subscribed to an external application, right? So you can basically leverage Cloud PubSub to decouple your system and components hosted on Google platform or any other internet system. So this is a very highly scalable system. So you can have messages being sent in few thousands, in few KBs to in few GBs of data, and millions of data that you can send across the system, right? So there is one system that we have in place. Then we also have Dataflow, the data transfer services, which is basically helps you to move the data from any other applications to BigQuery without you writing even a single line of code. So, for example, if your data might be residing in multiple other cloud instances, or if your data is an application like Adobe Analytics, or it could be Google Analytics, or it could be LinkedIn or ads data that you want to bring in, without writing in a single piece of code, you can just use the UI within our system to basically transfer the data from either on-prem or multiple cloud into the system. The third one is IoT Core. So IoT Core is basically a fully managed service that basically helps you to kind of easily connect your devices, your IoT devices or the sensors to Google Cloud. So it basically helps you to connect it. Once you connect, the flow of information can go through the IoT Core. So it's basically a fully managed system to connect, manage, and ingest data from a lot of disparate devices into our system. So these devices need to use some standard kind of protocols like MQTT and so on, which basically helps you to publish your data to the system. So that's on the collection part. On the processing part, we again have different systems to one get this information from streaming application like PubSub. But if you want to do any kind of transformation or any kind of other transformational activity, then probably you might want to use some of the system like Dataflow, which is basically a runner for Apache Beam pipeline. So if anybody of you might be already doing that, and you might be using some other technologies like Flink or Storm or any application, you can run the same pipeline on Dataflow. The advantage that you get is it's purely serverless, right? So you don't need to provision and so on, and it automatically scales depending on the traffic that you have. So you might have a traffic which is like few records to a few millions of records, which automatically kind of scales it up, right? Dataflow is a managed Hadoop instance which you can run it on Google Cloud. So if you are already running this on-prem or if you're running this on other cloud instance like EMR in AWS, then you can just bring the same system into our application. A few advantages on Dataflow is a highly scalable system. We also have something called a serverless part, which doesn't require you to again provision the system and run it. You can run that directly within the same application. It also has a lot of OSs like Trino, or what we used to call as Presto DB. If you want to run Spark jobs, or if you want to run any kind of Jupyter notebooks on top of it, you can use the same system to run. All both the system Dataflow and Dataflow, what I was referring to, both requires you to be good at programming, either it be Java or Python or Go or any other languages. What we also brought to the table is something called as Data Fusion. This is nothing but a managed offering of CDAP, which is again an open source technology. And if you want to create a highly integrated system which is agnostic to database or application without writing a piece of code, you can use Data Fusion for that. Right? Behind the scenes of Data Fusion, you use basically Dataflow for running all your data pipeline, either as a batch process, or if you want to run this as streaming one, you can also use Spark to do that. We have a fourth flavor for the processing part, which is data prep. The difference between data prep as against the other flavors of data fusion and data proc and data flow is data prep is purely an AI-based data preparation tool for doing any of your wrangling. So if your data is not very good and if you are not very great at your programming, so data prep would be the kind of tool which you can use in order to quickly sanitize or cleanse your data. It's an automated tool which basically helps you, provide insights on the data, provide you some data inconsistency that you have within the data, and help you to create any kind of batch pipeline within the same system, right? So that's on the processing part. The third part is storage, right? So now we also have different types of storage. It could be a MySQL or a Postgres database, which we have as a managed services. You can also use Cloud Spanner to basically store all this information. If you believe in putting the data into a data lake, just like a blob store in Azure or S3 bucket in AWS, you can also use Google Cloud Storage to do the same thing within Google Cloud. It has a lot of advantages in terms of versioning of your assets that you're storing within our system and so on. We also have a data warehouse we call as bigquery. It's a petabyte massively parallel processing data warehouse. It's an MPP data warehouse, which basically runs on few petabytes of data. Again, just like most of the technology that we have, it's all serverless. That means you don't need to manage all the infra. You don't need to keep all this infra ready for running any of your analysis. But you just need to focus on the queries or the machine learning models that you build within our data warehouse. So that's another system which we can actually store the data. BigQuery stores the data. If some of you might be knowing it, it stores the data into a format called as capacitor format, which basically takes care of all the compression. It basically has the data in a columnar file format. It also has a logical metadata operation for all your caching, buffering, and all your general data management kind of activity. It was developed by I think Moshe Pasmansky. He's the person who actually also worked on this MDS language, basically a query language for all your OLAP database. He's the same person who has actually designed the terminal engine for BigQuery. This is based on the capacitor format, which was developed by him. It's basically a next generation kind of columnar storage format, which replaces the historical format like column IO and all. If some of you might be aware, column IO is the same which helped in designing Parquet or ORC kind of framework. The same framework is now designed on BigQuery at a much larger scale. So that means the performance of all the storage is much higher. So usually, if you have heard about the historical data warehouse, the historical data warehouse performance degrades as the number of users are using the data, right? So, for example, if I have 1 terabyte of data and I have 10,000 users querying at the same time, my system just gets ruptured because it will not be able to handle such huge volumes of time. a huge volumes of people playing the data. But in the case of the capacitor format, you will never have these issues, right? So that's on the BigQuery storage part. Then we also have BigQuery compute part, where the computation happens. And the computation happens in a system called as the Dermal engine, which is basically a multi-tenant cluster that helps you to kind of execute standard SQL queries. These SQL queries, what happens behind the scenes is it basically executes into execution trees, and then it identifies how many slots that is required for you to run your analysis. So again, BigQuery is not just a data warehouse and use all these activities of doing your computation and so on, but it also has machine learning inbuilt into it. So that means you don't need to take the data outside your warehouse for building your any kind of analysis. But if you want to run your machine learning models within the BigQuery, you can do the same. We also have Dataflow, serverless part, which you can run on the same data which is stored on BigQuery or cloud storage or database. And finally, once you have all this data, you can connect this to any BI tool, so that Tableau or Power BI or any other application. So else you can use Looker for creating any of your dashboards or any kind of analysis. We also have Cloud Composer if you want to orchestrate your workflows, especially from a data processing till analysis. Then you can use Cloud Composer, which is a managed Apache Airflow instance that we run on Google Cloud. All the systems, whatever we spoke about, are all fully managed, serverless, and enterprise scale. Most of the systems are globally distributed, and it is very highly secure, both in terms of data, whether it's getting transmitted and whether data is getting stored. We also provide additional level of security, especially when you want to identify or when you want to scan all the data sets that is stored on GCP, plus redact those information. Let's take an example that I have so many data which is spread across. If, say, for example, an origin says, okay, how much information or PI information are you exposed to? Within GCP, it's as simple as just using something called as data catalog. Within data catalog, we have something called as DLP, which basically goes across all the data assets and identify which are the data assets, whether it's in a CSV format or whether it's in data warehouse format. And it basically mentions whether these database or data warehouse has any PI information. If there is a PI information, and if you want to redact those information, so a specific set of users should not see, you can do the same. And this across all these applications, whatever I spoke about. Going to the next slides, some of the design goals that we believe that customers need to look at is these things, right? From a data pipeline perspective, I'm pretty sure many of you have worked on data pipeline and you have realized that running data pipeline is not easy. So whatever the pipeline that you have designed for batch might not work for streaming, right? So what we believe is it should not work in that way. So the same system what you've done, built for batch processing should also scale up for the stream processing system. So we have a unifying way of stream processing and batch processing. We also believe in no ops. That's an important attribute that we believe that in most of the IT environment, it needs to be automated, right? And kind of abstracted from underlying infrastructure, and there should not be any need for a dedicated team to manage software in-house, right? So it needs to be completely managed by the vendor. So that's where your no ops comes into play. We also believe that it should be kind of serverless, fault tolerant. That means a system that has the ability to kind of continue operating uninterrupted despite any kind of failures in one or more components. It also needs to be kind of auto scale, or it should be auto scaling. That means it needs to enable organization to scale the cloud services, such as all these servers, the compute instance, the virtual machines up and down automatically based on the defined situation, such as the amount of traffic that you are having or amount of utilization that you have on a specific system. We also believe that it needs to be kind of transparent. That means whatever you do in terms of the data pipeline to the final data storage, they should be an image. People should see how, from which sources you have connected to, what kind of transformation that you have, what's the impact on certain specific type of transformations that you have done, and then store this information. That's for the first part, which is data pipeline. And the second part is data storage. Within data storage, we believe that the same capability of whatever spoken data pipeline in terms of no ops, serverless, this should be really important. In addition to this, we also believe that data enrichment is an important activity, right? So one is the part of data which you already have and the part of data what Google can offer to us, right? So we also have some of the public data set like COVID related data set. We have places data set, which is basically useful for analyzing geo kind of information. And this could be data from Google Earth data, which tells okay how what is the crop in a specific Latin long is all about, right? Or even weather information and so on. So that's where your data enrichment comes in. Again, with data enrichment, you have two types of type of data set that we provide. One is the public data set, which is free of cost. You can just directly access these data for running any kind of your analytics. Or it could be data which is a commercial data set. So, for example, the weather data. You need the weather information in a specific Latin long every minute, every second, and you want to use this in your existing application. Now that's going to be a bit charged, data that you have to go for. Another one we believe in terms of data storage and management is not only the data, the system should be highly scalable to petabytes, but it also needs to have systems like AI and machine learning within the data warehouse. And this is really crucial because what we realized is most of the organizations take the data outside the data warehouse and run their analysis. There are two issues when you do that. One is it is not a scalable model because your applications might not work, right? With few petabytes of data that you have, just copying the data into an external application for running your analysis, it takes a lot of time. Plus, it's duplicating all your data sets. You can have a serious security issues in the later stage. So we believe that whenever you run your analysis, just have it in your data within your data warehouse. The second, as I mentioned again, the security issues, that means you are always copying this data and you cannot make it real time. So all your systems needs to copy the incremental data for your analysis, and that will kind of delay your versioning of your models and even deploying the models in real life. So it's important that most of your analysis should be done within the warehouse rather than taking it outside the data warehouse. So finally, once you have the data, once you have stored the data, once you have a system in place to do all your data warehousing part, the analysis part is more important. So we believe is you need to have not just a system which does analysis on the data which resides on one of the vendors infrastructure, like in this case BigQuery infrastructure, but it could be data which might reside in multiple other places. So for example, I might have my data in S3 bucket. I might have data which is in Azure Blob Store. I don't want to bring the data down to BigQuery. Instead, I will actually use the compute instead of BigQuery to run my analysis on all this multi-cloud systems. The advantage is you'll have a single pane of glass to run your queries. Behind the scene, it could be any other cloud instance where your data is stored. We also believe that the same instance should offer for any kind of real-time and batch reporting. A great use case could be an IoT as a use case when you want to create a digital twin, and all this IoT and sensors information is coming in real time. And this could be millions of records which is coming in real time. Still, I should be able to bring the data in real time and create my reports in real time. We have a system to do that. We also help democratize all these insights. That means not only you will be able to create your reports and your dashboards on your system, but if I want to provide this intelligence into other channels, let's take an example that I have WhatsApp, I have Facebook Messenger, I have SMS, right, as different channels, and my users want to interact with the data warehouse through these channels, I can also do that. I can make it purely democratization of intelligence from my data warehouse to the end user, the final users will be consuming them. The same system should be able to kind of be available into any app. That means if I want to provide insights on an app, I should be able to do that. Finally, the best practices. So because this is not something which is new to Google, we have been doing this for a long time. We were pioneers in this space for a long time. What we believe is whatever we have done, some of the best practices that we're already doing from a data pipeline or data storage and management and analysis, we have some blueprints that we provide to the customers to adapt to our new technology. Then finally, the few things that a lot of folks really need to ponder upon is portability. Does the system, if I go from GCP, is the system can be scalable to other cloud vendor? These are all not proprietary technology. That means you have this system running on Google infrastructure, and if you want to port this across other infrastructure, you can do that. right? Only reason is because you're not paying for the license of the software. It's just infrastructure that you're using in order to run our analysis. What does it mean is it basically, because you're not using any proprietary software, it basically reduces the cost, and the performance is the same performance that you see on Google technologies. So whether it's the Google app, Google Analytics, or it could be YouTube, the same infrastructure is what we provide to our customers to run this. And most of this data, whatever we spoke about till now, is secure. It has all the best practices that we follow in terms of the governance practices and so on. What we'll do is we just go deep in each of the section and explain about what Google has offered to each of the space. As we were explaining from the data pipeline perspective, Google PubSub is a real-time messaging system. It's basically a asynchronous messaging service that basically decouples services that produce events from the services that process events. So you can use PubSub as a message-oriented middleware, or what we call as the event ingestion and delivery for stream analytics pipeline. PubSub kind of offers durable message storage and real-time message delivery with kind of high availability and consistent performance at scale. It also provides both push subscription and pull subscription. Some of the use case that I would inform the audience is the same system is being used by some of the social folks, right? Like, for example, we have Twitter, who is actually sending millions of data points to PubSub and pushing this into the data warehouse for analysis and stuff. Now, the PubSub system is integratable for Dataflow. It's again a runner for Apache Beam pipeline for any of your processing. So PubSub, just imagine this is more like a message broker to send the data. It also has some of the global routing, single endpoint from different applications, which basically helps to publish and subscribe to events, regardless of any geographic locations where the data is getting generated. So, for example, we might have data which is generating from US or data which is getting generated from India. You'll actually see very less latency when you do your analysis, because it is purely a global routing solution. So some of the key capabilities, it has at least once delivery. It has open APIs and client libraries in more than 7 languages that you can use. It provides cross-cloud and hybrid deployments. So you don't need to provision anything here. You just need to create an endpoint, and it will scale automatically depending on the number of messages that you can send. So it also helps you to seek and replay if there's any backlog of any data that is still not being subscribed by the subscriber. It also helps you to do data topics. That means any message that was unable to be processed, it will actually reside this in an offline environment so that we can examine and debug this in the later stage of the activity. It also provides filter messages of any kind of data that you have. So if there are certain messages that need not be sent or needs to be sent to a different subscribers, you can also do the filtration with the same PubSub system. So this is on PubSub. The second part is on Dataflow. So Dataflow, as I was explaining, is a ETL tool that we have. It's nothing but a runner for Apache Beam pipeline. If anyone of you would have run Apache Beam pipeline, you can write Apache Beam pipeline with either Python or Java or Go, right? It's a and then you can use this code and run this on Dataflow. It's a completely managed service for executing wide range of data processing patterns. The Dataflow system is a truly unified stream and batch data processing that's completely serverless. It's very fast and the most cost-effective solution that we have. It basically is nothing but when you can use Apache Beam SDK, which is basically an open source programming model that basically helps you to run your pipeline code as batch and streaming. So some of the advantage that you have is you don't need to rewrite the code for batch and streaming. You can same code, it's single code, and you just need to change the source. So if the source is PubSub or Kafka, it becomes a streaming system. If the source is a database, or if it's a GCL bucket or S3, it becomes more like a batch process. So you don't need to modify too much of your code, just the source and the destination. remaining the system will automatically understand. So you can also do this both as the Java or Python programming. But if you want to run some of the SQL statements in a real-time streaming kind of flow, you can also do that using something called as Dataflow SQL. Again, that's other mechanism of running your data pipeline. As I was explaining, I'll not go too much details. I'll just go to the next slide. The third option that we have is data fusion. So data fusion again is the third different way of creating your data pipeline. It's a fully managed cloud-native enterprise data integration services. The front end is data fusion, which is nothing but the CRAP, open source CRAP. The back end of running this pipeline is nothing but your data proc. So some of you might have known that data proc is nothing but your Hadoop instance. So if you're running the same solution on-prem, this will be Hadoop, which will be running, or either Spark or Hadoop, which will be running. If it is on AWS, it will be EMR, right? Or if it's in Google Cloud, it will be Dataproc, right? So that's how the system runs. It has a broad set of connectors, pre-built connectors. You don't need to build these connectors. We have connectors which is agnostic to any kind of database. So if your source is S3 bucket, or if the source is blob store, or MySQL is hosted on-premise, or Netezza or Oracle database, or any other database, you'll be able to connect to the system. Without writing even a single line of code, we can connect to the system, create a pipeline. If you want to do some kind of filtering, or if you want to do a PII information scan, and you want to redact those information and store that information, that means if you want to do any kind of transformational steps in between, the same system will run it, right? You can also operationalize this using a REST API and kind of extend this capabilities with a lot of other SDKs. As I told you, it is database agnostic. That means it can just access any kind of source system. It can do all your extraction, transformation, and finally, it can load to any Google ecosystem, or it could be other application which is on-prem and so on. So some of the applications that we spoke about are all database. It could be not database. It could be streaming system like Kafka or Cloud PubSub, or it could be applications like Mixpanel or Facebook, or data from hospitals like Excel server FHIR format. And if you want to convert or do the transformation, we have some pre-built connectors to that. We also have pre-built connectors to SAP. That means if the source is SAP, and if you want to create your own pipelines or from the SAP as a source, you can also do that. And finally, you can actually push these results into anything. Right now, whatever I'm showing the sync part is all Google Cloud, but that need not be Google Cloud. It could be other systems in place. So if you see whatever we spoke about, this is more like a front-end UI. Behind the scenes, there's a data proc that runs. Once you do this, you can actually push these results into BigQuery, and you can use some of our reporting tools for reporting from the data which we have. So I just switch one of those this one. So one of the other things which we have heard from a lot of people is in terms of the metadata and modeling, right? So I might have multiple data sets and want to understand what are the different data sets that I've used in my data pipeline. What is the lineage of my pipeline? Is there any impact on the changes that I had recently made on my application database that has an impact on my data pipeline? All these things is managed within the same system. It has a lineage mechanisms to identify what was the source which was connected, what is the type of transformation that was used. If there's any issues in the transformation, that they also specify the issues or the impact of that transformation, and then pushes the results to your application. It also has a UI which tells how many times this particular pipeline was running. If there are any issues with the pipeline, it will also provide a log file which says these were the issues that we have found. And it will also provide how many records were inserted and how many records were output into the set. So it provides an end-to-end data pipeline for doing this activity. So just to give you an example, this is the data lineage one. It shows that the pipeline that was created was from 3 different sources. Once we created the sources, we did an aggregation. First, we merged this information, and then we aggregated this information, and we merged this information based on certain unique identifiers, like in this case, for example, partner name or the offer name. or the service products, right, or usage type. It provides you a one view about the metadata or the lineage of your data sets. So as I told you, it need not be in one system. It's open. It's kind of hybrid. That is the same applications. If you want to run it on-prem or other cloud instance, you can do that within the same application. So as I told you, it's a seed app. It's an open source. It doesn't need to be just on Google Cloud. If you want to test it on-prem or on your desktop, you can also do that activity, right? So it's purely API driven. You can run this as a batch process and as a real time. That means the only difference in real time and batch is the source and the destination, right? So you can do that in this way. So just to give you an example that how does it look like so that people can visualize this. This is how data fusion looks like on Google Cloud. So it will have the data wrangling part where you can wrangle the data, integrate the data, replicate the data, or even do some governance of your data. If you want to monitor the data, pipelines, you can monitor it, and finally you can manage that. So replication is nothing but your CDC. That means I have the data, which is my database. Whatever changes that I experience in the database should be available in the data warehouse. So if you want to create a CDC pipeline, then you can use the replicate. So just to give you an overview, when we spoke about it to be agnostic to any data source, what does it mean? It means it can just connect to any data source that you have. Like be any applications like Facebook, it could be any database, data warehouse, it could be log data which is getting generated. It could be SQL Server or MySQL database. It's completely agnostic. You can run within the same system. Just to give you a perspective on how it looks like once it runs, let me just show you with an example. So this is one pipeline that I've already run. I'll just duplicate this pipeline and show how it looks like when you create it. Yeah, so this is how it looks like. So this is a batch pipeline. I have two different data sources. I've wrangled the data. I did some group by operation and joined the data, and then finally have the data being stored in the query. Now this is a batch pipeline. If you see batch pipeline, these are the different sources of data that you can use. If you're creating something like a social media analytics application, like I want to get all the tweets from all my applications and then store it into my data warehouse and then run my analysis, then you can potentially use a real-time pipeline. Right? Let me show you the latest state. So any kind of transformation that you want to do in terms of record operations, in terms of encrypting your data, or even decrypting your data, or redaction of your data, or even if your data is in MP3 files, maybe audio recordings, and you want to create a speech-to-text model, right? You can create a pipeline within the same interface. And then finally, if you want to parse your document, like for example, you might have data which is a PDF document, right? A handwritten PDF document, and you want to parse the document and store the data into BigQuery, you can also do that. We also have something called invoice parser, which is part of our document AI, which you can use within the same template. Finally, if you want to sync this data into any other external application, you can also do that. Just to show you, the same thing runs even for real time. The only difference is the source and the destination. So if you see in source, in batch, you had so many sources, but in this case, it will be all real time. So if you had Twitter, Twitter development environment, you can actually bring the Twitter speed streams into Google Cloud. So it's a simple UI. You can easily build this. It hardly takes time for you to build because you don't need to write even a single line of code. But even in the future, if you want to write any Java script or Python, you can also do that. Right? So we also provide JavaScript or Python script or a JSON parser if you want to kind of parse or run any kind of programming on top of this application. Okay, so let me just go back. So that's the second part. The third part is on the data prep. So as we are explaining most of these technologies, the first two technologies we spoke about is on programming. You have to write Python programming or Java and then run it on Google Cloud. And Google only provides infrastructure for you to run, right, in a more efficient way, right? Both this data fusion and data prep is more like you can build this entire ETL tool without writing a single line of code. Data fusion, as you saw, you need to be a data engineer. You need to know what data source you're requesting for, what kind of transformation you want to do, and store it. Now, data prep is purely designed for business analysts. So now you might say that, okay, what does business analyst has to do with data prep? Ask any data analyst, they will say the majority of the time they actually spend is on data preparation, preparing the data for analysis. What we do is we make their life much more simpler. So it's an AI-driven tool which you can use for exploring your data. It's as simple as just connect your data source and specify what kind of data preparation that you want to do. The system itself can tell you what kind of data preparation you have to do. So there's two mechanisms. One is you know what to do. Other ones you don't know what to do. You want the system to identify any issues with your data and do certain kind of recommendations. So Google Data Prep does that in a more efficient way. It provides an AI-assisted data preparation tool to identify the issues that you're facing. And if you want to run specific tasks, like if you want to standardize the data, the system also tells you what kind of standardization that you can potentially do to make it more specific to the use case that you're trying. So it is a tool that is powered by Factor, which is the industry's leading data prep tool. It provides three simple things. It's purely serverless. You can quickly do fast data exploration because it's all UI driven. It provides assistance for doing it, and it's easy for any kind of data preparation. Finally, data stream. So data stream is nothing but a CDC tool which Google has in order to bring the data from any of your source system and replicate the data into your destination. So the source could be Oracle or MongoDB or MySQL, and the destination could be PubSub or BigQuery in other system. It's basically a CDC kind of tool which basically helps you to do that. Again, it is purely serverless, so you don't have to configure and run this system at scale. So you can start off with a few instances, and when the throughput increases, the system can automatically scale by itself. And finally, once you do all this data pipelining, you might want to push this data into a data warehouse. So what do we have in this space? We have BigQuery, which is a petabyte scale data warehouse. What we call this is to be a data warehouse as a service. So that means you don't require no upfront hardware provisioning or management. And this single queries can cover petabyte size data sets, right? And utilize thousands of CPUs, which is distributed across hundreds of machines. While you're not running the queries, you only pay a tiny amount of money for the data which is being stored. It's purely based on distributed architecture, which is basically used for by BigQuery for identifying the compute resources that is required in a more dynamic fashion, and it can also manage compute clusters within BigQuery and run your queries in a more efficient way. So again, if you see the way we have done this is you don't need to size or plan any of your data warehouse. You can just focus on your code, run your queries, and we will do all the managing of the number of workloads that is required for running it. Because of this, you don't need to over provision. Usually, when you want a data warehouse, you have to provision it. You have to say that this many virtual CPUs or DWDs that is required. In the case of the tools, have to do that. It's also elastic. It scales elastically. It also kind of separates your storage and compute and provides a variety of benefits because of this, right? So because we decouple, storage and compute, the storage could be anything. So storage could be BigQuery storage, it could be cloud storage, it could be a database like MySQL or Postgres or Bigtable. So that could be the storage mechanism, and we can run your queries on top of that. So there are instances where you have data which might be a CSV or a Parquet, and you don't want to bring the data into the BigQuery and want to run wherever it is, which we call as a federated query, you can do that. Now, the federation has not stopped on Google infrastructure. It means if your data is in AWS or BigQuery, which is multi-cloud, we can also run the queries on top of that without bringing the data into one centralized location. So that's on the BigQuery side. Some of the key capabilities that we have is this petabyte data warehouse. So what does it mean for some of you? You might be quite interested to understand what do you mean by petabyte, right? So let's take an example that, okay, I have this data which is coming from an e-commerce company, and this data is around 1.09 petabyte of data. That means I have 1 quadrillion records which I need to process, right? And this data is purely semi-structured. It is in arrays and structs. So for example, if you see this is one sales order and you have it in an array, right? So this is actually one record to our system. So if you see from other data warehouse perspective, this might be a single table which has all the product information. Then I have information of my sales order, the transaction data in a second, and then I create a star schema or a snowflake schema to do it. But in this case, we are running the same thing in one single large table, right? And for this, I'm going to run this analysis, right? So I'm going to just do a bit complex analysis where I'm running simple running average with respect to different products across different days. And I'm actually getting the product information from a second table. And these are actually joined based on some primary key. So in this case, it is the product key. I don't require all the products. I require the products with respect to specific regec expression, and I specified this is the regec expression that I require the data to be. So I don't need all the products, only which has this patterns, right? So once I run this, and right now I'm not caching the result, that means I've not run this prior to this. It's not getting the data from cache, it is actually running this directly on the query. This should not take much time, right? So usually it should take no more than 40 seconds to run this. It should take less than that. So right now what's happening is it's actually running this, provisioning some of those instances, and it says because you're running this on specific time frame, right? So in this case, I'm running this between 1st of January 2011 for 7th of January 2011. It's just going to that partition and then bringing this information out. And doing this analysis, this petabyte data analysis, it hardly took 17.3 seconds to run this analysis. And finally, you have this data for running your reports or analysis. So that's what it means by petabyte scale. Again, I didn't specify saying that I'm going to run this query on petabyte. So let's everybody stop using BigQuery and let me run this query. So you don't have to do that. It completely is no ops kind of thing. That means you don't require admin activity to do. I didn't specify the system that because I'm going to run this, maybe I want so many instances of virtual CPUs to run it. So the system automatically understood that because I'm going to run it on some petabyte of data, it needs to automatically provision so many instances to run the compute instance. So all these things are working in the backend, and you just focused on the query rather than focusing on the infrastructure. Yeah, as I told you, it's a high performance streaming API. That means it's the same BigQuery storage. You can actually use it into any other application. So, for example, if I want to run my analysis on the data which is stored in BigQuery, I'm going to use Spark or Hadoop or any other systems. I don't need to use the BigQuery compute. I can just use BigQuery storage API to just talk to the storage and run my analysis. It also has an in-data warehouse modeling where you can build your machine learning models within the same interface without going multiple different applications. It also has geospatial analytics so that you can run your analysis on the same system. It also provides BI engine for fast in-memory analysis services. So what does it mean when I say that is, if you see here, I have this data and I want to do a quick explanation of this. I can just say I want to do a quick explanation of this petabyte data, either using Google Sheets or Data Studio, and I can visualize the data. So it's as simple as that. I'll go through some of the demos in the later stage so that you understand that the same petabyte data is now going to be used quickly for your reporting analysis. Now, the same tool is being used by a lot of customers across the globe, right? Some of the customers have some of the largest queries, which are like 10.5 trillion rows that they run. We ran this on 1 petabyte of data. It hardly took 2 seconds, maybe 17 seconds to run that. We have some of the largest customers who are running this on 5 petabytes of, the largest queries on 5 petabytes, right? We also have some other customers who are storing this on 250 petabytes. That's the capacity which we are talking the system is able to run. Plus the peak ingestion rate, and this is really important, is whatever we spoke about right now is all batch kind of environment. But in a real-time streaming environment, it can also be used, right? So that means if I have 4.5 million rows that is being inserted per second, I want to run my analysis on these records, I can use the same BigQuery interface to do that. None other data warehouse in the market can scale this, high as compared to BigQuery. One of the reasons is it's the same engine that we use for Google Ads, Google Analytics. That's the same tool which we have externalized for users to run this at scale. Okay, from the analytics perspective, we have Data Studio for creating the reports. As I was explaining, this is a BI tool that comes bundled with BigQuery. So whenever you run any analysis, You can just go to explore the data studio and start exploring the data, right? So again, this was a petabyte of data. Now I'm going to create reports on this petabyte of data. Now, the first step is you don't need to go here, but if you run the query and you want to analyze, you can do this. And you can specify, I want to quickly create my reports or dashboards on this data studio, right? So when I click this, saying that I want to create a new report, it goes to a different interface, and then quickly you can build your reports or dashboards here, right? Now, it need not be this. You can actually specify that I want to directly go to the source system and run it, and you can create the report. That's one mechanism of doing it, right? Or else you can do it in a different mechanism. Like, for example, in this case, I just say I will add data. I have a BigQuery instance that I'm running. The data will reside coming from this specific project of Rakesh Mohandas. And I have some data which I want to quickly run my analysis on. Like here in this case, I'll say I have a employee churn data. I'll just select this data and I can quickly run my analysis, right? So you can mention what data assets that you want to run, or else you can even run a custom query. Let's say you can run a simple SQL query to run this. And let's see what we can quickly build, right? So this is the entire data set that we had. And if you want to create a report or a dashboard based on that, you can quickly create that, right? So for example, I have a number of records that is coming in. I also want to create the same one in terms of what is the average age group. I also want what is the daily rate of churn. I also want to have hourly rate, right? So I can just go on adding these attributes. And once I create this, this will be the total customers, right? So I'll say this is total customers. Then I can just add one more attribute, which is daily rate, right? So this is the average daily rate. So I'll specify this to be average instead of sum. And then I can say what's the average age group of these people who are churning, right? So average age group, I can just select average. I think I just use the same one, sorry. And then I can say the daily rate, average daily rate. Then I can say I want to see the performance rating, what's the average performance rating that people have. And then finally, distance from home, right? So I'll just add distance from home, average distance, right? So, and here I'll just select this as average performance. Then if I want to add more attributes to it, like for example, I want to see year-on-year performance. So in this case, I don't have year-on-year, so I'll not use that. And I want to see with respect to different type of activity that people do. What is, like for example, with respect to gender, what is the attrition rate, right? So I'll just use gender, and I want to see the attrition rate. And I also want to do a cross-filtering between different data sets. So I can do that here, right? If I want to create something like a tree map, again, with respect to different set of users, like for example, in this case, I will specify that with respect to educational field, I want to see what is the average performance rating. And so I can have that here, right? Or else I can say, I just don't want to see this one attribute. Maybe I'll add multiple attributes. One is the average performance rating. Then I want to have average age. Within average age, I also need to have, like for example, hourly rate, average hourly rate, and so on. So what happens in this case is when I view it, I can just switch between different metrics. Like for example, performance, age, and hourly rate, and I can see the same metric at different instance, right? And finally, I want to create, say, for example, animation plot. I can also do an animation plot here, right? So here we don't have it restricted time. That's why I'm not going to use an animation plot, but you can also use that, right? So if you also need other types of plots, that could be done. So if you see, this is on petabytes of data, right? So if I just click on this medical one, right now it doesn't work because I'm not cross-filtered. But if I do a cross-filtering, that means if I just click on medical, I'll see what is the average, well, how many males and females are there in specific category. If I use human resources, it shows that 70% are male and 29.6 are female and so on. So you can quickly create all these dashboards and reports in no time. And this data is one of the very spoke. We said it's a petabyte data, right? This petabyte data from data to insight, it hardly took any time for us to create, right? So let's go back. Similarly, again, as you saw, you can build your reporting both as a batch data. So if the data is static, you can build the same reports, or if the data is dynamic and new data comes in, you can also create a real-time report. So we similar to Data Studio, we have an enterprise BI tool which is called Looker for any kind of reporting or dashboarding. That's another tool that you can use. You can also embed this tool into your external application. Like for example, I want to embed this on my app or my website or my native application without having the Looker logo or any other systems. You can also do that. You can call this as an API to our application. The advantage that you get with Looker is it is multi-cloud platform. That means your data can reside anywhere. It need not be just on Google Cloud. The data studio, you need to have the data on Google Cloud or Google ecosystem, or at least have data which is in a specific file format, like a CSV and so on. But Looker is not that. So Looker is a multi-cloud platform. I mean, that means if your data resides in Redshift or data resides in S3 bucket or any other data warehouse or database, you should be able to connect to that and create your reporting. It also has in-database architecture. That means whatever report that you create runs within the warehouse. It doesn't create any queue. That's a great advantage. Data Studio also does the same thing. It runs in database. It also has a common model to all your data, which is called as a lookup, which you can use for any of your reporting. So finally, on the data governance, we believe that we have a lot of data sets that is spread across Google Cloud and even on-premise or other non-GCP data sets. One of the biggest challenge that we heard from customers is how do I manage these assets, right? How do I know that there's so many assets? How much of those assets has PI information? Who is accessing it, right? So data cataloging becomes really crux. It is what Google Data Catalog does is a kind of a fully managed, highly scalable data discovery and metadata management services. It basically helps you to simplify all your data discovery at scale. It's the same technology which is being used in Gmail and which is being now externalized for users to access it. So if your data resides in GCS, pops about BigQuery, what it basically does is it identifies whatever data assets that you have. It has a semantic search capability, which helps you to identify what kind of data that you are searching within your data ecosystem and brings it into one single UI. And if you believe that this information contains PI information, you can let the system go and scan this information. So we have something called as the DLP API, which can go across all the data sets, access or assess the data sets, and then say which data sets have the PI information. If you believe some of this information needs to be redacted, you can also redact this information in the same system. Now, redaction and scan will not be on structured data sets. That means it may not be a database or a CSV file. It could be images. Like, for example, I have a PAN card. I uploaded a PAN card, and I want the system to identify that there are so many PAN cards residing in certain places in your data set. And if you want to redact those information so that nobody steals that information and gets that information out, we can also use a DLP API for that. Yeah, so this is on the data catalog, some of the key capabilities that we have. It does something called auto tagging using machine learning. It identifies what kind of data that we have, whether it has a name, mobile number, email address, and so on. It also has data discovery, which has the semantic search capabilities to do that. So this is what I had for today. I think we are running short of time. We have 3 more minutes. Any questions, Steve? I think, Avinash, I think we'll have less time for the final demo, which I was just was planning to do, but I think I'll just quickly run the through it. So team, because we are running this hackathon and we believe that you want to use some of these big data capabilities and to your front-end UI, you can also do that. So great example, which I want to just quickly run in the next few minutes, is something like AppSheet, right? So AppSheet is a tool which basically you can create your app, right? You can create your reports, you can create a loan form, right? You can create or upload or do a document digitization, right? And even you can do a route planning on the same app. It's a no-code UI which you can use in order to build this. Behind the scenes, you can use any application, right? So in this case, whatever I have used, if I just go to my account, I have integration, right? So this integration could be a data store. In this case, if you want to digitize your documents, it could be a document AI system that you're going to use. But the data storage could be a Google Cloud storage. So you can use Google Cloud storage to connect it. It's as simple as just specify that I'm going to use Google Cloud storage. You provide the private key, which you generate from our system, and you can also provide the bucket name. So once you have done this, you can click on connect and see that it's been connected, right? If you believe that your application requires some data sources like some database and so on, you can also use that. So you can use Google database, you can use cloud database, on-prem database, or anything. If you're using Google database, then you can actually use what you call BigQuery, or you can use MySQL or Cloud SQL and so on, right? So just one minute. So just to give an example, I have this BigQuery integrated to my application, and I can just specify I want to add a new data source, say for example, in this case, cloud database, and I can specify either SQL query or DynamoDB or a BigQuery, right? So once you specify BigQuery, you can specify the data set ID or project ID and the service account, test it. Once you test, you will have your apps integrated into this, right? So you can just have an app just like this, and you can download this as an APK and then present to the user. So the front-end UI could be something like an app that you design, and the backend could be any data warehouse or any application, right? So you can actually see all your maps and everything being linked. You can create your own, kind of application, and then you can, build your own same system. So this is what I had. This is something which I would really request some of you to try when you're building this application. Yeah, so I think here it is. Sorry, I just missed that. If you see here, this is the tool that you can use. You can connect to a data source. So one of the data sources that I'm connected to is BigQuery. You'll have an UX where you can create your, forms. It's very simple to create your forms. And then finally, once you want to do any kind of reporting, you can do it here. Like for example, this backend database is nothing but BigQuery, right? So we are just connected to the BigQuery. It hardly takes a few minutes for you to create this app. Once you create this app, if you want to white label them, you can white label them, and you convert this as an APK, right? And you can use this APK for any of your hackathon that you're planning. So I would recommend most of you to just try this out. This will really help. So this is what we had today. So I'll just let all of you ask questions. Any questions, Avinash, so far from the team? Yeah, Vishwanath.
So Rakesh, I think a couple of questions, I already answered. So I've unmuted the participants also. So in case if anybody is interested to ask me questions, please feel free to unmute yourself and you can speak.
Yeah, Vishwanath.
Hi, Rakesh.
Hey, Vishwanath.
Yeah,
Good evening.
so I'm just a little bit deep dive into data catalog and
Mhm.
some other product like data fusion and data computer. Data computer and data fusion, a little bit I want to understand the difference between data fusion and data computer. So in
Yes.
which case will use the data fusion and which case will use the data computer?
Yeah. So data composer is used for orchestration, Vishwanath. So when I say orchestration, it means like I have 5 different systems which I'm going to use. Like for example, I generate this data. This data first goes to, say, for example, Google Cloud Storage. Once it goes to Google Cloud Storage, there should be a event-based mechanism which identifies there's a new data which is came in, and then it needs to run a pipeline, right? Once it runs a pipeline, the pipeline should run once the data is available, and then it needs to push into BigQuery. Once it's available in BigQuery, it needs to run a script, basically doing the aggregation and then storing the information. Now, there is 4 to 5 processes that we have done, and these are 4 to 5 different applications. So if I want to orchestrate these applications together, I use Cloud Composer for doing that, right? Now, do you think Data Fusion does that? No, it doesn't do that. So Data Fusion, what it does is it integrates between multiple different database and applications. It does a good job of ETL, but not a good job of orchestrating multiple applications together to start. So these are 2 different purposes. One is for purely orchestration. Other one is an ETL tool to do it. So if you want to compare this, it's as comparable as using data stage as compared to using Airflow.
Okay, and just give some idea about catalog, but you explain all the details. I understood, But some practical point of view, where you will be using data catalog.
Yeah, so data catalog, just imagine, Vishnu, like you have, say, thousands of assets, right? So I have CSV files then spread across thousands of CSV files, which is stored in GCS, right? Google
Mhm.
Cloud Storage. And I
Okay.
have